All right, good afternoon, everyone. Hope you're still awake. This is right about the time where things get a little dicey, I usually find. So hopefully we work through this. You can't see the presentation coming up, but I can. The title of this presentation is IoT, or the Rise of the IoT Applications. It's kind of a little bit of a play on words. If you've ever heard of the rise of the machines. I used to be, I've watched too many science fiction movies and read too many science fiction books not to be worried about a dystopian future. And then I look at the state of robotics and the state of what we're doing in the world and how good or bad artificial intelligence is and how easily we can fool it in some cases, and I go, well, okay, we've got some time. Okay, it's not going to happen yet. And still, I do find that after working in the IoT space for about 4 years now, I find myself asking more and more, what's the right thing to do, as opposed to, can I do it? Well, it's more, should I do that? And if I'm going to do it, how should I do it? So I think it's important to keep these topics in mind as we connect the physical world and the digital world more and more. Along the lines of the rise of the IoT applications and the implication of the rise of machines, at IBM, as we look at our Watson IoT offerings, we're taking a particular interest in how we make an Internet of connected things, whatever those things are, how we make that advantageous and assistive to humans. In particular, how we can engineer better things and how we engineer and build stuff, how we manage things and manage our environments, whatever those environments may be, and how we interact with things and the environment. And so our IoT applications that we are building work along the same lines of engineering applications and solutions and equipment, engineering a better world, managing equipment and solutions, and interacting with solutions and the world. And so you'll see our solutions actually bring together characteristics of analytics and artificial intelligence and human-computer interaction, as well as system design, system implementation, deep, dark engineering, and management aspects. We concentrate our solutions in a number of areas, and you can see here an overview of what these areas are. I'm going to spin forward to the second version of this chart to show you for each of those areas kind of what we are working on. In the manufacturing space, we build solutions around predictive maintenance. In the vehicle space or transportation space, two areas: connected fleets. What would you do as a fleet manager or a management of a fleet of equipment? How would you want to manage that, maintain it, operate it, optimize what you're doing with that equipment? A connected car space or a connected vehicle space. A lot of our demonstrations are showing things that we could do in vehicle dashboards with assisting drivers, where the driver is kind of centric to what we as humans would think. But I'll always ask you that when you just think about the broader view, when you look at any of those demos, you say, well, okay, what if the driver is somebody different? There are a lot of heavy equipment drivers in the world. We're not to the point where every truck, bus, tractor, and so forth is autonomously driven. So assisting those individuals who are driving and managing those vehicles as well is a space that we are working in. We work a lot with connected appliances and connected equipment, whatever you want to call that. You can think of that as anything from elevators to washing machines to connected coffee pots in the world. And then we also are working on how to optimize equipment. We are working in the areas of, one of the latest buzzwords in IoT is this thing called digital twin. I heard it earlier called digital clone. If you think about that, once you've instrumented some equipment and you have information about how that equipment is operating, you'd like to bring that information back to the design and engineering teams so that they can better craft the next versions of that equipment that they are going to bring into operation. Likewise, you would like to bring that information and make it available to service technicians that are out in the field trying to make adjustments to that equipment or identify which equipment needs the most attention and in what order. And so you can use that information to sort of round trip the design, management, and development process that you follow with respect to any of the equipment that you're building. Interestingly enough, for the computer science students in the audience, just a quick show. Who's heard of DevOps? Yeah? The notion of continuous delivery of software. Yeah? The idea that I should be able to write a line of code, and as if by magic, it finds its way into whatever the operating environment is. I submit to you that the same idea holds true into a physical world as well. And as my colleague Mac pointed out earlier in the afternoon, as you spread computational logic out into the world, there's also a need to manage, maintain, update, and operate that software that's spread out into the world as well. And so if you think about this whole round-trip process of design, engineer, test, build, deploy, manage, operate, and so on, I expect that in the future we'll want to take software engineering tasks around continuous delivery and DevOps and apply them into physical systems and the Internet of Things, where we're deploying a continuous delivery updates into that equipment that is out in the world. We're a long way from that right now. Most equipment isn't even thinking about how to update its own firmware, or if it is, you guys are probably all familiar with this with one or another devices. You're involved in the process. You get a shoulder tap when iOS wants to update, and you get asked, is that okay? That's fine if the device is associated with you, the human. But if the device is not really associated with a human operator, that doesn't work. And so the device itself has to understand when it's ready to be updated and how to update it and so forth. I'm going to move ahead here a little bit just to talk a little bit more about our solutions. We work from a wide variety of applications. We work in the industrial and energy and utility space around asset health. So we've been working in equipment maintenance, predictive maintenance, and so forth for quite a while, even before IoT was a household term. But we're also thinking about how to manage those assets better by leveraging information coming in about those assets. So if I know that a particular piece of equipment is being used heavily, whatever heavily might mean, used, abused, driven heavily, rolled over rough terrain, was out in a physical environment that was I don't know, particularly rainy or dry or hot versus cold. That asset health can be measured, and that can then be used to understand which pieces of equipment need to be serviced and maintained in which order. Another area, I spoke about predictive maintenance. We're working with vehicle manufacturers around predictive maintenance and quality. This again, once I can instrument equipment and instrument devices, I can feed that information back and then make a determination as to which equipment is in need of service in which order. Who has a relatively new vehicle from either, say, Mazda or Honda? I have one, okay? I don't own the Honda, my son does, but he gets free oil changes at the Honda dealer. Isn't that great? They don't want to see the car until the oil indicator is at 15%. It's not connected yet, but it's a sensor technology that speaks to predictive maintenance as opposed to scheduled maintenance. So it's an easy way to think about how this is going to extend into a more connected world. As those vehicles become connected and that information is fed back directly to the manufacturer, you can envision how that same thing would occur, that my son doesn't have to remember to go call someone, but rather the vehicle schedules the appointment based on what the sensor readings are. That further gives information back to the vehicle manufacturers to understand how their equipment is being used in real-life driving conditions. So what you can test in a lab and what you can test in the real world are very different. So why not take advantage of the real-world driving conditions of your user community as a means of gathering information about how your equipment is used in practice to help you design better equipment. And so that's what we're doing in that case. We also work a lot in the facilities management space. And buildings are becoming more and more connected all the time. We see that you've seen this for a while in terms of PLCs and building control systems, but we're starting to see those because those have been in the past relatively self-contained. But we're seeing them brought together into a larger connected space, and information coming from those things being used to help determine what to do for facilities management and how to manage those assets. I spoke a little bit about washing machines before. We actually do quite a bit of work with connected appliances. Our customers, in particular Whirlpool, are trying to provide a better user experience for their user community, whoever might own a Whirlpool product. By the way, Whirlpool is one name, but they also have many other brands by which, in the US and across the world, by which they deliver products and services. You can think about better warranty services, better product design, and even the idea of automated replenishment. So wouldn't it be nice if you didn't have to even think about a dash button, but the device just said, hey, I really need to be replenished with some detergent. I'll order it for you, and it will happen to show up on your doorstep. We're also seeing that in the future, you might not actually even buy an appliance. We're finding that businesses are coming to a point where they're going to start offering physical equipment as a service, not as a pay-for operation. And in order to provide that equipment as a service, they will take on the management and maintenance of that equipment, and they'll have to know what's going on with the equipment. So IoT will enable them to be able to provide a completely new business model. Consider the case of, I don't know, you'll buy washing as a service, or you'll buy a cooktop as a service. And as part of your service, you will get a new cooktop, maybe, on a particular schedule. Or you might get a new feature without necessarily even asking for it, but it'll show up because of your usage characteristics. They found that you'll be more apt to like this product or use it if you have a new feature added to it. An IoT talk and a talk from IBM cannot be made without mentioning the one-word blockchain. Indeed, we are working with various customers on the idea of marrying the Internet of Things with blockchain ledgers, blockchain fabrics, and immutable ledger of operations and transactions that have been performed. I have worked with several customers who are thinking about use cases, particularly in the area of parts provenance or equipment or goods and equipment tracking as it moves through space and time across multiple parties. So if you think of what happens to a piece of manufactured, I don't know, doesn't really matter, some manufactured widget. It could be a toy, it could be running shoes, it could be an expensive pump that is manufactured in one location in the world and has to make it to across three other continents before it's going to be installed somewhere. Well, how did it get from one point to another? What were the conditions of that shipment as it made its way from one point to another? And who was really involved to get it from one point to another? So when I buy something off Amazon, how many companies are involved in getting that that piece of merchandise to my doorstep? Turns out quite a few. Even in the US, it's not just UPS or not just FedEx, and that's just the shippers. There are various logistics companies involved. There might be shipments that last on the order of days or weeks over which things occur. And what was the condition of that shipment as it moves through space and time? The idea here is that organizations today don't have a lot of visibility, traceability, or transparency in that space. And a ledger that is immutable, meaning I can't go back and cook the books, is a way of providing a means for tracking and showing what the state of that physical system was as it moves through space and time. Again, that can apply to parts provenance. It could apply to pharmaceuticals. It could apply to any type of shipment that you're working on. Likewise, there are a wide range of pieces of equipment strewn about the world that are managed and maintained by a group of companies. Just think about this building. Not everything in this building is maintained just by the university. There's probably 3 or 4 contractors involved that manage different pieces of the building. Well, there's different parties involved. They have they have a symbiotic relationship, shall we say. Okay, they're kind of actually mutually distrusting. They've entered into a contract with one another. They've agreed that that's how they're going to do stuff. But everybody's kind of looking, are you really holding up your end of the deal? Are you really doing what you're saying you're doing? Is it really operating the way you expect it to? And by instrumenting the elements of the building that might be maintained and operated and owned by different parties, with a log of what's going on, what changes have been made, what operations have been performed, and how the equipment is operating in a ledger, those parties can interact better, have more transparency, and have a quicker turnaround time on what they've typically been communicating in the past. In the past, it's how do these organizations communicate? They pick up the phone, they send an email, they fax, yes, they even scan and fax things. And so the order of communication is on the order of hours, days, maybe weeks. With a blockchain ledger that everyone is sharing this information, they all have access to it all the time, you can knock that down to the order of minutes or seconds. So you can see that the transaction rates don't have to be astronomically high in order for a blockchain environment to be useful, especially when working in the physical world, because you're coming from an environment where it was days, weeks, or months. If you can get it down to hours, minutes, or even seconds, you're way ahead of the game, okay? And you're providing a better quality of service. And so that's why we see IoT and blockchain having a nice fit with one another. We also do a lot of work in the manufacturing space. We're doing things in the area of visual analytics as well as acoustic analytics. The idea is using machine learning algorithms to help us assist in manufacturing quality assurance, essentially visual recognition of defects, parts that need to be serviced, and so forth, as either they come off the assembly line or if they're used in practice. If we can take pictures, determine what's going on with the equipment, and then feed that into an asset management system, we can use that information in an automated way as opposed to having to send someone out or find someone to visually inspect it. Likewise, we are using the frequency domain and frequency analysis of sounds to do to use the audio information to understand if particular equipment is working within or outside of what its expected operating ranges are or its expected normal state of operation. Has anybody ever listened to an engine? You can listen to an engine as a human, you can go, yeah, that sounds cool, that sounds nice, really good. And then you hear something a little bit off. So the same idea is to take what we can do as humans relatively quickly and apply similar technology with audio analytics and audio analysis, I mean. All right, I mentioned the notion of digital twin early on in this presentation, and I'll come back to it here. Really, this is the idea, as I said, of really going from the design, prototyping, and implementation stages to instrumenting whatever that physical equipment is, so that you can then feed that information both to management and operations teams, as well as back to design and engineering teams, so that they can better update what they're building. If this were a software environment or an IT system, you'd be doing monitoring of the systems, you'd be debugging problems, and you'd be rolling out new software. Or you'd be rolling in new hardware into what might have been your data center to respond to capacity planning changes. If you take that same model and spread it out to a physical system, we can apply the same and similar types of processes and technologies to provide a better round-trip service and a better quality of equipment produced. I do work on IoT security, so I felt that I would be doing a disservice if I didn't talk a little bit about IoT security before the end of this talk. And so this is a set of 5 items that we put together quite a while ago now. It was probably over a year ago that we put this together. But the reason I find it useful to continue to show is that if you look at each of these 5 things, with exception of perhaps the point about data accumulation and exposure issues increasing, if you look at each of these, if you look at the other 4, you'd say, if you were using a computer, you'd say, I would never do that stuff. That would be dumb. Right? I would never consciously install a default user ID and password, because I know that any default user IDs and passwords are going to be well known even before whatever that piece of equipment is hits the shelves. And yet, a lot of the equipment that we get has them in it. Easy stuff, folks, okay? Software security will degrade over time. The point there, and that we've learned it when we realize these things are computers, we've learned it, okay? We now accept app updates all the time on our mobile devices. We're like, yep, okay, I got another one, just another day, okay? We now accept that we have to update software in our laptop computers and our data center systems and everything in between. And yet we're not thinking that we have to update the firmware and the devices. Why not? You know, if there's a problem in the SSL protocol, or sorry, in the TLS protocol, so that we have to upgrade to a new TLS version, well, if the equipment and the device is using TLS, why wouldn't we have to update that as well? Okay. The point there is that if you're not setting up a piece of connected equipment for online update, for firmware update, then in effect, as the tide rises around you, essentially as attackers get smarter and new attacks are generated and the world gets smarter about what's going on, you're held down like a boat anchor affixed to the floor, to the sea floor, while the tide rises around you. And so software, you must be ready to update your software. Weak configurations persist. The point at the top there, a big difference between the computer equipment that we work with all the time and IoT devices is that the IoT devices, I think, operate in much more hostile environments. They're much more hostile from a physical perspective. They operate outside, they operate underground, they operate underwater. They operate in very hot conditions and very cold conditions. And furthermore, they operate without human intervention. You know, there's not someone standing around the connected traffic light 24 hours a day. Yet there is a person standing around every one of these, sort of by definition, because it's in my pocket, okay? So devices do operate in hostile environments, so I'm asking you to think about that. The point of the one on the last one there about as data accumulates, exposure issues increase. there's more and more data more and more data collected all the time. This will not go away. It will happen. And as computers and machine learning tools and technologies and data analysis techniques continue to increase, the ability to make inferences based on that data will also increase. And so what was considered to be private information before, or even anonymous information before, when connected up with other stuff, we'll find that it won't necessarily be 100% my personal information, but with a high degree of certainty, it was my information. So even though it was anonymized, people will be able to say, oh yeah, that route that was taken by that vehicle that has no person identified with it, no way. Everything expunged, I just know it was a vehicle. Well, guess what? That's Tim's commute. It's about the right time of day for when Tim usually makes that commute. Probably an 85% chance Tim was in the car at the time. And so this accumulation of data will cause these new characteristics to emerge. And we need to be aware of that and prepare for it. So with that, we are doing really exciting stuff with IoT applications. If you want to learn more, it's a really short URL right there at the end. Only 9 letters. How hard could it be? I appreciate your time. Thank you very much. And I look forward to talking to you throughout the end of the day.